For this question, we're supposed to figure out, right, that a transition from energy level 0.54 to 1.51 eV correspond to which part of the EM spectrum. So we have a 0 here. So all of these kind of questions, right, I'll always just draw a simple diagram. So we have a minus 0.54 and a minus 1.51. If you have done your book work, right, this is a very straightforward question. It's simply infrared, because, right, this transition going from here to here, what's the energy? Around 1 eV. Okay, 1 eV, right, falls just under the visible light one. So let's take a look at the EM spectrum. So starting with visible light, right, you have red on one end, violet on this end. For corresponding to red, you have around 1.7 eV. Okay, so it's energy slash EV. Violet is around 3.1. Okay, so anything that's here, right, or infrared will be less than 1 or less than 1. Okay, we just need to know a rough range. As long as it's lesser than red, it will be infrared. And usually, right, we don't deal much with infrared because these energy are too small. They don't cause much quantum phenomenon. So none of the experiment that we are dealing with is talking about less than 1 eV, and hence, right, we don't see infrared appearing in context other than this question. Yeah, and let's continue with the rest of the spectrum. So above 3.1, that will make it UV already. But I'll just give a more generic one. I'll just say that this is 10 to 100 EV. More than 3.1 to 10 also considered UV. But I'm just giving you a range, okay, an order. So tens or hundreds, you'll be UV. Then when you have thousands, okay, so you have KeV, right? How much? 1 to 100 KeV. Okay, as long as you are still in a KeV range, consider X-ray. Then once you reach the MeV range, then this will be gamma. Okay. Yep. So these numbers, right, are crucial. So you must memorize these numbers. Yeah. So that in certain situation, you do a calculation, you will know whether your answer makes sense or do not make sense. From the concept point of view, you see, if you are dealing with emission absorption line spectra, you should expect a few EV, because emission absorption line spectra is visible light. Okay, and if the answer is not a few EV, you know you must have made some mistake. Similarly, when you're dealing with X-ray emission, if your answer is not thousands of EV, you must have made a mistake as well. So it is crucial, absolutely crucial, to know all of this. Okay, so yeah, so that's just for this question.